Welcome to LabMinutes.com and our lab video series on MPLS. You can find a complete list of MPLS video on our website by clicking on the link above and sign up for our newsletters to receive the latest video updates. In this video, we're going to look at how we can implement MPLS Traffic Engineering constraint-based routing using LSP attribute. And some of these attributes are going to include priority, attribute flags, and affinity and path option bandwidth override. And then we'll see how we can assign these attributes to a tunnel using attribute lists. We will also check out the way to have the tunnel automatically calculate the required bandwidth, so we no longer need to statically reserve bandwidth for the tunnel and potentially waste the bandwidth along the path when the tunnel is minimally utilized, and this is going to be done through a feature called auto bandwidth. For our physical lab topology, we have 8 routers, R1 through R8, and one switch 1, although we're not going to be configuring R8 and switch 1 in this lab. Here in the middle, we have our router R2, 3, 4, and 5 connected in a full mesh topology across 0 point-to-point link, while the other routers are connected across layer 2 VLANs as shown in this diagram. Okay, for our layer 3 topology right here at the middle orange circle, this is our MPLS core that's been enabled with MPLS Traffic Engineering from the previous lab. So we already have basic configuration in place where there's LDP, MPLS Traffic Engineering command. Since we're running IS level 2, we also have Y metrics and all that configured already, and we're going to be using the loopback 10 through 12 on the router R6 and R7 as our test subnet, and these has also been advertised into ISIS. Okay, just make a quick note right here. We have a table that contains various tunnels that we're going to be configuring throughout this lab, just so that we can make a quick reference as we configure those tunnels. And we also here have the tunnel attribute or parameter listed, so we can make comparisons when we're trying to figure out how each of these tunnels makes the routing decision. Okay, so let's get started with our task number 1. And task number 1 is pretty much going to only deal with preparation for our following task. So first we need to configure an attribute flags on links using the following values. So a link between R1 and R4 will be a hex value of 3, R2 R4 will be a hex value of 11, and R3 R4 will be a value of 9. Okay, and then we need to reconfigure some of the reservable bandwidth on these links, which are R3, R5. And we're going to lower from a regular T1 speed down to just a 512, and the same thing with the link between R2 and R5. Okay, so if we refer back to our diagram, you can see that we already have those links kind of labeled with the adjustments that we're about to make. So first, let's start off with our router 1, which is modifying the attribute flag on the fast01.14. Okay, so on R1, we interface fast01.14, and the command to modify the attribute flag is MPLS Traffic Engineering attribute flag. You can see that it accepts a hexadecimal format, so it'll be 0x3. So if you're wondering what exactly is the attribute flags, it's basically just nothing but a value that you assign to a link that later on is going to be utilized by the tunnel attribute called affinity, and we are going to explain this in more detail when we actually start dealing with the affinity in a later task. Okay, but for now, let's just go ahead and reconfigure some of these links with the flag. So next will be our router R2. So router R2 needs a flag of 11 and a bandwidth of 512 between it 2 and R5. So next goes to R2, interface 0000, MPLS Traffic Engineering, attribute flag 11, and for the serial towards R5 is 010. There will be IP RSVP bandwidth, and we're in kbps, so that will be 512. Okay, next will be our router R3. Router R3 right here. We need to make a changes on 2 links, very similar to what we did with R2. So 0000 MPLS attribute Traffic Engineering attribute flag 9, and then 010 IP RSVP bandwidth 512. Okay, now on our router R4, we have to deal with 3 links just to set the flag. So first we'll do fast01 MPLS Traffic Engineering attribute flag 3, and then on serial 000 there will be 11 And then for interface 010, it will be 9. As you can see that we're dealing with a number of links here, so it might not be a bad idea to print out the diagrams just to have that right in front of you, and that way you can follow along with our configuration much easier. Okay, next is our router R5, and that is to adjust RSVP bandwidth down to 512, and that's 000 and 001. Okay, so R5 interface serial 00, IP RSVP bandwidth 512, and then 01 512. Okay, so let's just do a quick verification. Since all of these links informations are advertised all around the network, so just by looking at that on R1 using the Show MPLS Traffic Engineering topology, we should be able to spot some of the changes. As you can see right here, this is the link from R1 to R4. The flag is now 3. Okay, that one is 0, that one is 0, but you can see the bandwidth for that has been lowered to 512. That one is still a T1. That one has a flag of 11. Okay, just do a quick sanity check and make sure that we are seeing the values that we just changed to. Again, that will be a value, flag of 9, and bandwidth of 512. So it looks like all of our changes has already taken effect. So now we can move on to our next task, and that is pretty much all we need to do for our task number 1. Okay, next is our task number 2 with auto bandwidth. We have to configure a MPLS TE tunnel 1 from R1 to R2 to automatically calculate bandwidth from the actual traffic as often as possible, but not to exceed the value or bandwidth of 500 kbps. And we need to use the following parameters. Okay, and that includes auto route announce. And in this little table right here, we're going to leave priority and affinity values at default. The path it's going to take is through R1, 3, and 2. Again, it said right here for the bandwidth is going to be auto bandwidth. That would never exceed 500 kbps. Okay, so the path that this one's going to take, it's just going to be straight through. Get that? So R1, R3 to R2. Okay, so that would be our tunnel 1. Configuration is going to be completed on the router R1. First, let's specify our explicit path, and the name for that is, let's call it R132, since that's the exact path it's going to take, using the next address command. And we're just going to do the loopback IP for that. So first hop will be a router R3, so 0.3, and then 0.2 for the router R2. Then we create our tunnel number 1 with IP unnumber, loopback 0, just reference to loopback 0. And then for the tunnel destination, it's going to be terminated on router R2. So here's our router R2 loopback IPs. For the tunnel mode is MPLS Traffic Engineering. Then we need to use the auto route announce for the forwarding. So we auto route announce. Okay, we already talked about the auto route announce back in the MPLS tunnel forwarding videos. Next, we need to specify the bandwidth to automatically be calculated. So right here, there's a command called auto bandwidth. And just to quickly talk about auto bandwidth, so basically what that's going to tell the router to do is to monitor the actual bandwidth utilization of the tunnel and then periodically make the adjustments. So that way the router can basically increase or decrease the tunnel bandwidth value accordingly, and we don't have to hard-code the reserve bandwidth on the tunnel. That helps preventing you from undersubscribing the bandwidth of the tunnel as well. Okay, so here we specify the auto bandwidth command, and then we have a few options that we can do. One would be the frequency, which is how often you want the router to make that assessment and make the adjustment accordingly. Then we also can limit as far as the maximum bandwidth, that you don't want the bandwidth to be reserved more than certain values, or you also want to guarantee that even though there's less traffic, you still want to reserve the minimal amount of bandwidth. So here the task said that we do not want to exceed 500. And I believe it's also said that make sure the router make the calculation as often as possible. So when we configure the frequency value, we're going to pick the lowest possible value, which is 300 seconds. And for our max bandwidth, that's going to be 500. Okay, and that's in the unit of, again, kbps, so 500. The last thing we need to do is to type the explicit path to the tunnel. So tunnel MPLS Traffic Engineering, path option 1, explicit, and we give it a name R132. Okay, so the tunnel came up, and now if we do show MPLS Traffic Engineering tunnel, you see that currently, since we don't really have any traffic going through the tunnel, the bandwidth that's being claimed by the tunnel is 0. Okay, and we can also prove that by doing a show IP RSVP interface, and you can see that even though out clearly the tunnel is currently up, it has not made any kind of bandwidth reservation out of the fast00 interface, which is the interface that's facing R3 right here. Okay, so now that we have this tunnel number 1 established, that should pretty much complete our task number 2,